Hi everyone, myself Nithin Heraje, Assistant Professor, Department of Computer Science and Engineering, AJ Institute of Engineering and Technology, Mangaluru. In this video, I will be discussing about wireless LANs. So just an introduction to the wireless LAN. As you can see, these two diagrams over here. So this is a wired LAN, whereas this is a wireless, where we call this network as a ad hoc network. Okay, so it's a wireless connected nodes or the host. Uh, so here in this, we can connect a wired network to a wireless to a wireless network, and we can connect to the internet through the router. Okay. These are the four characteristics of wireless networks. First one is that attenuation. So the strength of signal, that is electromagnetic signal, will be decreasing because of different factors. The energy or the signal will be lost. So only not a complete portion, but a small portion of the signal reaches the receiver. So that's what the attenuation, wherein there is a drop in the signal. Next is that interference. So as the name indicates, there is an interference will be there between the sender and the receiver. That the receiver might receive signal not only from the intended sender, but also from other senders too, which might be occurring because of the same frequency band that both are using. Next is that multipath propagation. So here a receiver may receive more than one signal from the same sender, because electromagnetic waves can be reflected back from obstacles such as walls or objects. The result is that receiver receives some signals at different phases. This makes the signal less recognizable. So whatever the sender sends the signal, that does not travel in a single path. It will travel in a different paths, that is multi paths. So which might cause the receiver to which might cause the receiver to have a difficulty in recognizing the signal that is sent from the same sender. And last one is that error. So this happens because of these three characteristics, right? So there might be an error, that is the sent signal will not be as the same as the received signal, and these above three characteristics might be the reason for this. Under access control, we have a hidden station problem. You can see here there is station B, A, and C. So C has the range like this. Okay, this is the range of C, wherein within its range it has only A. That means C knows that in its range it is having only node A. But wherein other side, even B has a certain range. Even B includes only A within its range, which means that C does not know the presence of B, and B does not know the presence of C. Similar thing is here. B and C are hidden from each other, but both can see A. So what happens in this case is C also simply sends the data to A, B might also send data to A at the same time, which might cause to the collision. Okay, so there might be a collision in this, which is not detected. Okay, so that is the problem of hidden station. That is, collision will not be detected because of hidden station problem. Next, coming to IEEE 802.11, which is a standard set by the IEEE for wireless LAN. Coming to the architecture, it defines two services, that is a basic service set and extended service set. So we'll look into it one by one what it is. In the basic service set, we'll just look at this figures. So this is one figure which has an access point, and all these nodes are connected through access points. Whatever data it has to send, it will be sending towards through the access point itself. Okay, so this type, it is called as infrastructure BSS. Alright, whereas if you look at this, there is no access point as such, and there are nodes you can see over here. Here the nodes can set up a network among themselves, which is called as a standalone network, so they can communicate with each other. What is the difference with the access point and without access point is that these can communicate only within this ad hoc network or a standalone network. They cannot communicate with the outside network. Whereas if there is access point, then this network can communicate with the outside network. Okay, and this is called as infrastructure BSS. So that's the use of access point over here. Next is extended service set. So in extended service set, there are many BSS connected together to a distribution system. Okay, through a router, and this you can see, this is a wired connection to the distribution system to all the access points, and this is a individual BSS infrastructure. Okay, so here what happens, so these can communicate with other BSS also, so that's called as a extended service set. Next, coming to the MAC sublayer, which is divided into DCF and PCF, that is distributed coordinate function and point coordination function. Normally everything takes care with the distributed coordination function. Only if a timing concept to come across, then you go for point coordination function. So let's see what is distributed coordination function. So the two protocols defined by IEEE at the MAC sublayer is DCF and PCF. So DCF is one of the protocol, and it uses CSMA-CA as the access method. So how they exchange the frames, we'll just look at with this diagram. Okay, so here what happens is, if a source want to send some data through the network to a particular node or a destination, it will sense the medium until it is idle, depending on the signal that is there in the medium. So once it identifies that the medium is idle, then it will wait for DIFS, that is distributed interframe space. Once waiting for DIFS, and if still the medium is idle, then it sends a RTS frame, that is a request to send frame to the intended destination. So B is that node that it wants to send. And here now B will receive this request to send a frame, that is saying that A wants to send some data to B. B will wait for SIFS, which is a short interframe space, and then sends a CTS frame, which is nothing but the clearance to send the data. So again A will wait for SIFS, so that is short interframe space, and then it starts sending the data. Okay, so at this point over here, B is going to send CTS to the source as well as to all the nodes in the network. So it also sends CTS to C and D, such that there should not be any collision. So this is NAV where after receiving the CTS, that is network allocation vector, that means already B is having some transmission. So A will send the data, and after receiving the data, B again waits for SIFS and then sends acknowledgement to the source as well as acknowledgement to all other nodes in the network, saying that it has completed the transmission. Okay, so this is how it works in distributed coordination function. Next, going to the PCF. So here it is with respect to polling. So these are the different nodes over here, and you can see that there is a contention free window. This is the contention free window. So it waits for PIFS. So PCF is given priority over DCF. So here it is not DIFS, it is waiting for PIFS time. After that, it has to wait for a bacon frame. This B is the bacon frame. Okay, so at the starting of a bacon frame itself, it starts with the network allocation vector. That is, no carrier sensing should be there after this. Then again there is SIFS concept here. So after waiting for a short interframe space, the access point will send the polling, and the polled station, that is this particular station is polled, it will wait for SIFS and it will acknowledge back to the access point along with the data that it has to send. So polling is nothing but access point is asking if any of the station has is having any data to be sent. So whichever station has the data to be sent, it will send acknowledgement along with the data. So it is going to send the data. Again access point will wait for some time, then again it sends the acknowledgement on receiving of successful data, plus it will again start sending the poll frames, so that any other station has to send, it can send. So after a certain time, that is contention free time, it will end the contention free window and then wait for some contention time, and this all together it is called as a repetition interval. So after this again there will be a repetition interval after the contention window. Next again the contention free window is going to start. Okay, so and one more thing is that this NAV starts with beacon and ends with the contention free, that is here at this point. Okay, next is exposed station problem. We had spoken about hidden station problem, how collision is not detected because of hidden station problem. In exposed station problem, it is a different case. See, if you're looking at this, the A wants to A sends a RTS frame requesting to send, for which this particular node C is exposed. Okay, and B will send the clearance to send, and A will send the data. Okay, A will send the data to the B. But what happens with the C is, see, if C wants to send it to data to D, then C will not send the data at this time because C is already exposed to RTS frame of A. Thinking there is transmission, C will not send any data to D. Though there will not be any collision if C sends the data to D. So which is a waste of time, right? It's a waste of waiting. Correct. This happened just because of C is exposed to A. Alright. So that is the problem. Though it can be done, it will not do the transmission. So this is a problem, and if it transmits also, there will not be any collision. So this kind of problem is called exposed station problem. All right. Next we'll come to Bluetooth. As we all are familiar with the Bluetooth, we know how Bluetooth is going to work. We can connect the gadgets together through Bluetooth and transfer the data. So this gadgets which is connected together through Bluetooth is called as a piconet. Okay, so we'll see what it is. So Bluetooth defines two types of network. One is piconet network, another one is scatternet network. If you look at this, this is the piconet network, where the different nodes are connected via Bluetooth, and one is made as primary and the rest is made as secondary. So the primary is going to transfer the data towards the secondary station, and all these secondary stations will synchronize their clock and hopping sequence with the primary node. Okay, so that's about piconet. If you look at this scatternet, you have two different piconets connected together. And if you look at this particular node acts as secondary for this particular piconet, and it acts as a primary for this particular piconet, right? So what happens here is this node receives the data from this primary, and it acts like primary for this piconet. So whatever data it received from this primary, this node will send those data to these secondary nodes. Okay, so from one piconet being the secondary node, it receives the data, and for the second piconet network, it acts like a primary node and it sends the data that is received from the first piconet. Alright, so that altogether it is called as a scatternet. Next, this is a Bluetooth layers. You can just go through this. What are the different layers that are there in the Bluetooth? Next, we'll move on to the cellular telephony. So, cellular telephony is designed to provide a communication between two moving units called mobile stations, or between one mobile unit and one stationary unit, often called as a land unit. So, cellular telephony is meant for communication between two mobile phones, right? Both the mobile phones are movable, or one mobile phone and another one would be a landline, where a mobile phone is a movable one and landline is a stationary one. A service provider must be able to locate and track a caller, assign a channel to the call, and transfer the channel from base station to base station as the caller moves out of range. So each cell contains an antenna and is controlled by a solar or AC powered network station called the base station. Each base station in turn is controlled by a switching office called a mobile switching center. The MSC coordinates communication between all the base stations and the telephone central office. So we'll look into this, what it is in this diagram over here. If you look at this, these are the mobile phones that are moving around, and this is the one cell. We call it as one cell, and this one cell has a particular frequency. Okay, and this is the border of this particular base station. So this particular base station will be given one frequency. right? This mobile station can move around. It can move towards a different station. Okay. How this communication happens is these mobile stations will communicate with the base station, and this base station, which we this call it as a tower, correct? Normally we call these are the towers, mobile towers. So which is basically called a base station, and this base station will communicate with the mobile switching center. Okay, this is a mobile switching center which will call to the telephone center office. Okay, which connects with the other base stations, or it connects with the other cells and other public switched telephone networks. Okay, all right. So this is the architecture of cellular telephone. Just look at this frequency reuse principle. So you can see this is one particular cell. This is called as a reuse factor of 4. That means we can have 4 different frequencies. So this one cell 1, 2, 3, 4 will have 4 different frequencies, whereas this cell and this cell will have the same frequency, but there will not be any interference in the frequency because there is some cell in between which has a different frequency. Therefore, there will not be any interference. Okay, so this is a 4 reuse factor of 4. So 4 different frequencies are used in this, and each cell over here, this is one base station, 2 is another base station, 4 is another base station. So each cell have its own mobiles roaming around, so that mobile can roam around with the different cells, right? Because these are each are different base stations. Similarly, this is a reuse factor of 7. That means 7 different frequencies are there in this. Okay. So how a call will be transmitted? So if you want to dial, so how it is going to happen? So to place a call from a mobile station, the caller enters a code of 7 or 8 digits, depending on whatever the numbers, and presses the send button. That is obviously the call button. The mobile station then scans the band, seeking a setup channel with a strong signal, and sends the data, that is the phone number, to the closest base station using that channel. So under whichever base station it belongs to, that is the mobile, it will send that data or the phone number to the base station. What this base station will do is it will just forward that data to the, that is the phone number, to the mobile center. Okay. From there, the MSC sends the data onto the telephone central office, so where the actual work takes place. So if the called party is available, a connection is made and the result is relayed back to the MSC. So this checks if the caller is available. If it is available, it sets the connection to the MSC. At this point, the MSC assigns an unused voice channel to the call, and the connection is established. So it assigns unused voice channel, and the connection is established with the given to the base station, and through base station to the mobile station. So sometimes you feel there is interference, so that's because of this. When the voice channels are mixed up. The mobile station automatically adjusts its tuning to the new channel, and communication can begin. So this is how this is from the caller side. Next we will see how it happens at the receiver's side, that is at the receiving end. When a mobile phone is called, the telephone central office sends the number to the MSC. The MSC searches for the location of the mobile station by sending query signals to each cell in a process called paging. So how this exactly happens is base station to mobile, mobiles to the base station to the MSC, MSC to the office, central office to again back to the MSC, where the receiver is there. and that MSC will send to the base station, where exactly it will find the mobile which need to receive the call. So it sends a paging signal. So once a mobile station is found, there is a mobile is found, the MSC transmits the ringing signal. So the mobile starts ringing, and when the mobile answers, it assigns a voice channel to the call, allowing voice communication to begin between the caller and the receiver. So this is what's happening in the receiver's end. Next is handoff. Handoff is nothing but see, the mobile station keeps moving, so it might switch to different cells, which is nothing but it might have to switch to the different base stations. So when the mobile moves, so one base station finishes off its range, then the mobile station has to be handed over to the next nearest base station. So that base station will take care of the communication. So this is basically called as a handoff. So there is two types. One is hard handoff and one is soft handoff. In hard handoff, what happens is the switching from one base station to another base station, the connection will be broken down. So that's why sometimes when you are moving, your call will suddenly get disconnected. This disconnection is just because of hard handoff. That is, when your mobile switches from one base station to another base station, the connection will be disconnected. During soft handoff, when you keep moving, you won't feel that handoff, that is from your mobile from one handoff to that is from one base station to switches to the another base station. But you can note this. You can just leave your mobile there. The network, the frequency will signal will be reducing. Right? When you are moving, the signal keeps reducing. That is, you are moving away from the base station which you are already connected. And suddenly the signal will be boosted and you will get a full range. This is because you have already handed off to the next nearest base station where you are closer to it. So you get the complete range. So this is called as a soft handoff. Okay. So there is something called roaming. So we know what is roaming basically. So what is this roaming is, say your service provider has some range, right? It has a limited coverage to provide you the service. If you are moving away from that range or the limited coverage, then you might get a service from the neighboring service provider or a different service provider, okay, which is called as extended coverage. That is through a roaming contract. For example, if you are using a BSNL tower in Karnataka and you move towards Mumbai, say where you doesn't have the BSNL service provider in Mumbai, but then you can have a extended coverage through a roaming contract, that is some Airtel or some other service provider might give you the service. Okay. So that is completely a different service provider, not your active service provider. So this is called as roaming. Alright. And you can see there are different generations in cellular network, which started with 1G, 2G, 3G, 4G, and the next upcoming is the 5G, okay, which is still in progress. It is not completely implemented. Currently we have 4G. So what you have observed through all these things is the speed of the data as well the quality of the voice. So you can see the different categories, the bandwidth and the different access methods and the technologies that are used. Okay, so these are the different generations and the comparison chart. Right. So that's it with the wireless module. So we have come to an end of module 5 of data communication. Hope you have understood whatever is being taught, right? Thanks for watching this video. If you like, please click on the like button. Thank you so much. Thanks for watching.